Emerging technologies, such as fan-out wafer-level packaging, silicon interposers, chip-on-wafer on substrate, and wafer-on-wafer, require design teams to work together to optimize the entire system, not just the individual elements. Often, collaboration between electrical and mechanical designs for packages are static, and work is duplicated within both domains to update the assembly as well as the library components in the design. In this example, we will be collaborating between Xpedition Package Designer and Siemens NX to show how to realize the digital twin. Typical collaboration between ECAD and MCAD starts within the mechanical world. The mechanical designer will create the substrate outline, dies, epoxies, and an initial enclosure to test the spacing requirements. A baseline file will be created to synchronize the mechanical and electrical data. This will synchronize the ECAD and MCAD objects, so subsequent changes will only contain the modified data. With IDX, the user has the ability to preview information and identify what data set he wants to import and what data he wants to reject. We can also import the initial heatsink for placement studies. Here we have an online DRC that allows us to specify potential interference issues in the 3D domain between the mechanical library components like the heatsink and the capacitors placed within the design. We can then send a proposal to the mechanical domain of only the newly added components from the package design in the electrical domain. In the incremental changes dialog, we can accept or reject any item, but in this case we will accept everything from the electrical designer. Additionally, NX will automatically create a response file of all items accepted or rejected to synchronize the electrical domain. Once the database is further, the mechanical designer can provide an updated heatsink that he can pass back to the electrical designer. Once the design is further down in development, the electrical design should have routing and copper elements associated with the package design. With Xpedition and NX, we can easily transfer this information in an external data file. In Xpedition, we have the ability to filter the copper data, whether it be by layer or by object, like traces, vias, component pads, plane shapes, or conductive shapes. Within NX, we can also filter the copper information and exclude data that we do not wish to import. We also have advanced rules to convert the copper data to specific layer information that's needed in the mechanical database. Once the design is imported, we can validate the copper information and net names in the mechanical domain.